There are many benefits to running LLMs or large language models locally and privately, to include, number one, cost. There are no monthly subscription fees outside of the cost to run the server itself. Number two, data and privacy control. Your prompts, conversations, and documents never leave your infrastructure, and you ultimately control the data. And third, you have full customization, including choosing different models, running your own authentication, and feeding it your own domain-specific data. That being said, here's what we're going to do in this video. First, I want to show you how easy it is to deploy your own private LLM. I'll walk you through how to deploy OpenWebUI in your own private Kubernetes cluster, and we'll grab a model off the open source project Ollama to run as well. Second, what point is it to run an LLM locally if you can't access it remotely to use as well? Thus, we'll set up Twingate to provide us easy, secure remote access, and we'll be deploying their new Kubernetes Operator to do so. This is going to be a lot of fun. Let's get started. So first, the obvious here is that you need a Kubernetes cluster. I assume that you have one given that you clicked on this video. If not, just head over to k3s.io and it's literally a one-liner. But again, I assume you have one. Next, let's get started deploying OpenWebUI. So if you don't know, OpenWebUI is an open source AI platform that you can host yourself, even offline. It provides the platform, and then you'll need a model or two to choose from. For that, we'll head over to ollama.com and find one that can run on smaller servers. So to deploy this, I'm going to use their Helm chart with a bit of a tweaked values.yaml file. And I'll be sure to include all of this in a repo for you to reference. Link will be down in the description. So head to Google and type in OpenWebUI Helm chart and choose that GitHub repo. And let's look for that values.yaml file. So click on charts, and then OpenWebUI, and let's open this up. So you can look through this values file and see what the defaults are. But again, I'm gonna leave you a reference down below to what I'm using. So a few things to note in this file. First, we've chosen the Llama 3.2 1B model. So if we go to the Ollama page, this model is actually small and provides a 1B and 3B model, which is small enough to run on our server. I've set some resource requests and limits, and then I've enabled persistence. So I'm running Longhorn, which will auto-provision my persistent volumes. If you're creating yours manually, then be sure to run the provided pv.yaml file to create your persistent volume, and then you can uncomment here as needed. So just go here, uncomment, set your storage class, and then make sure your persistent volume is named OpenWebUI PV. Again, I'm using Longhorn. It'll auto provision. I won't need that. And that's it. Everything else in the values.yaml can just be the default. And we're only going to pull in one model. Feel free to look around, but I would recommend, as most of us don't have large servers to run this on, to just pick a small model like this to begin with. So let's deploy this. If we go back to the Helm chart, go back one, there should be instructions on how to do that. So installing, run Helm repo add. To add the repo, run the update, which is just standard. So I'm going to SSH into my server that's running my Kubernetes cluster. And I'll create a file, sudo vi openwebui values.yaml. And I'll paste in our information. Save that. And let's go back. And next you can install the Helm chart with this command. So let's copy that, paste this command. Let's add a namespace of AI. And I don't think that exists, so create namespace. And then we want to point to that values file so we can override the defaults with what we set. And to do that, you just do values equals OpenWebUI values.yaml. And let's run it to install. And we can check our pods, kgit pods, namespace AI. And you'll see that this is creating. So this might take 3 to 4 minutes. I think this model is over a gig. So it's going to download this Ollama model. And our application will not be ready until that's done. So I'll give it a few minutes and come back. Actually, let's do a watch here so we can tell when that changes. All right, it looks like we're up and running. Now here, everyone's setup is different in how you access your private Kubernetes apps and how you do your ingress. I personally use Traffic as a reverse proxy. Maybe you're using Nginx Proxy Manager. However you do it, go ahead and set up your ingress so that you can access the app. It's on port 80. For demonstration, I'll just do a port forward to test this out. So I'll enter this command. And this command creates an SSH tunnel on 8080 from my Mac to my Raspberry Pi master server. And then does a port forward there on port 80. In this way, I can access it in my Mac browser. In that kubectl port forward is my service, OpenWebUI. So you can type this in to check it out, hit enter. And I can now go to localhost 8080, and there's my OpenWebUI. So click on Get Started. And let's enter a name and email and all of that. So I'll say Travis. Email, let's say travis@twingate.com. And a password. And create admin account. Okay, let's go. And here I have my LLM running locally. So how can I help you today? Let's say create a simple Golang server. Enter, and it should write this code out for me. And it's not going to be amazingly fast because it is a Raspberry Pi, though it is a pretty souped up Raspberry Pi. But if you have a more powerful server, you'll get better results. So now that we have a local LLM set up in our private Kubernetes cluster, let's now set up secure remote access so that we can easily access this LLM from wherever. So I can be away on a trip outside of my private network, and I can use Twingate to access this private LLM. And while there is a Helm chart to deploy the connector in our cluster, we're going to actually be checking out their new Kubernetes Operator, which will allow us to define our connector resources like this LLM, as well as policies declaratively in our cluster. And if you're not familiar with the term, a Kubernetes operator allows you to define custom resources and then manage and extend those resources via a controller. In the context of Twingate, it can define custom resources like a connector, a resource policy, and then manage these resources directly from within your Kubernetes ecosystem. Very cool. So let's go visit this Twingate operator. So in Google, just type in Twingate operator. And there's a page here about it. Quick blurb about it, but click on GitHub project page. And from here, click on Wiki, and down here, Getting Started. And we're just going to follow this guide. So if you haven't set up a Twingate account, just go to twingate.com, click on Try Twingate for free, and go ahead and create your network. And once you're inside, the first thing we'll do is click on Remote Networks. And a remote network is just a logical separation of resources within Twingate. This will represent our Kubernetes cluster. So let's create one. I'll just put on-premise and Kubernetes cluster. Add remote network. And that's actually all we need to do from the Twingate admin side. The rest we're going to do with our operator. So step one, go to your Twingate admin console, create a remote network. We've done that. And then create a new API key with read, write, and provision permission. So we do need to go back and do that real quick. So go to Settings, API, and generate a token. Read, write, and provision. Label, let's say Kubernetes. And generate. Copy that token. And let's go back to our Getting Started. Next, it says clone the operator's repository. I'm not going to do that. I'm going to use the provided Helm chart. And so I can skip down to creating a values.yaml. So this is sort of like how we did OpenWebUI. We're going to deploy it via Helm, and then we're going to customize the values.yaml according to what we need. So here it tells us to create this values.yaml with the following values. So Twingate operator, we have our API key, which we just obtained, the network, remote network ID, and then log format. So let's go ahead and do that. So sudo vi Twingate operator values.yaml. And I'll go back and copy this and paste it into my file. Now, I don't want to put my API key directly here. I'd rather create it as a secret. So if we actually go back to code and deploy in Twingate operator in this values.yaml, where we can see all of the defaults, you'll see that instead of using API key, we can use existing API key secret. So what I'll do instead is I'll create a secret and then use this to reference it. So let's save this. So we're going to run the command to create a secret. Before we do that, let's do kcreate ns Twingate to create that namespace. And then we're going to run this command. And instead of your API token, we're going to paste in the API token that they gave us. So let's copy this and let's paste that in instead. So this is just a secret called Twingate API token in the Twingate namespace. And the key is API token and the value is just the token itself. So let's create that. And then if we go back to our Twingate operator values, instead of API key, we can use existing API key secret. And actually there's an example right here. So let's grab that, paste that in. The name was Twingate API token. And the key was API token. And again, you can just put your API key here. This just creates a secret in the proper place and then referencing it here in the values.yaml. The network slug, what is that? Well, let's go back to the admin panel. And that, of course, is going to be whatever's here. For me, it's devrel. So whatever you've called your network, just the first part. And then remote network ID. So the ID of the remote network that we created. And actually, I can do instead of that, so remote network ID or remote network name. Let's just do remote network name. That makes it a little easier. So remote network name is Kubernetes cluster. And then for log format, put whatever you want. I'm just going to put plain. And that's literally it. So your API key, your network, your remote network name, and the log format. Once that's done, save it, go back to our instructions, see what's next. And what's next is just to deploy it. Now again, instead of deploying from the repo here, I'm going to go back to the code page and run the command they give you here. Helm upgrade TWOP, Twingate Operator. And this is just deploying from the OCI repository. So grab this, paste that in, and let's make a few changes. So instead of values, it is Twingate operator values. That's what we named it. And the namespace is Twingate. So Helm upgrade, TWOP. So remember to put your namespace and the values.yaml file. And you might be like, what is this -f? Well, we can do that. Or we can do like we did earlier, values equals Twingate operator values.yaml. So let's deploy this. Awesome, kgit pods in Twingate. And you'll see that our operator is already running. So let's go back to wiki and getting started. Now that we have that deployed, the operator introduces new custom resource definitions like Twingate connector, Twingate resource access. So what we'll do now is we'll set up Twingate like we always do, but instead of doing it in the admin panel, we can declare these parts as Kubernetes objects. So normally we create a connector, deploy it into our environment, and then define resources and policies as to who can use those resources. But we'll instead define all these as Kubernetes objects for our operator to manage. So going back to our getting started page, let's deploy a connector to connect your cluster to Twingate. So we have this new custom resource definition called Twingate connector. Let's copy this. And let's do a sudo vi connector.yaml and define this. Let's call it my Kubernetes connector. And then there's this image policy field. Now this image policy field will actually check and auto-update the image if necessary every day according to the schedule. So here you have this image policy link. If you follow this, you'll get the parameters for all of these resources. So if you scroll up, you'll have this Twingate connector, and then you can drill down into like spec. So here's Twingate connector spec, and you'll see image policy in that schedule defined. You can also define a provider, like let's make sure it's Docker Hub. Let's add that. So provider Docker Hub. To make sure we choose it from that. And that's our Twingate connector. Let's go ahead and deploy it. So when we create this Twingate connector object, our operator will provision a new connector and deploy it to the cluster. So let's create this, create f connector. And when we do this, the operator should go ahead and deploy this connector for us. And we can confirm that by going back to the admin. Let me refresh the page. And you'll see here we have a new connector called Neat Ladybug. So why did it name it that? Well, we can go back and check our documentation to see. So let's go back here to our API reference, find Twingate connector. And usually this stuff is under spec. So click on spec and you'll see a field called name. Name of the connector, optional if not specified, Twingate will give it a random name. Hence the Neat Ladybug. So let's go back. And let's do a delete f connector. We're going to delete that. And we'll make sure we give it a name. So let's do name is my Kubernetes connector. Save it. Create it. And let's see if that comes up with that name. So refresh. Here's my Kubernetes connector, not connected yet. There it goes, it's connected. And the reason why this is yellow is when you create a remote network, it creates two connectors for you for high availability. I don't need that. I actually don't need either one because I'm doing this from my Kubernetes operator. So I'm just going to delete them both. And once I do that, it'll be green. I can deploy another connector and have HA if I need, but I don't need that in my home network. All right, so we have our remote network. We have our connector defined in Kubernetes. Now we can create a resource. So going back to the documentation, we've created our connector. Next, we're going to define our Twingate resource. What's that resource going to be? Well, it's going to be that LLM that's now running in our private Kubernetes cluster. So let's copy this and do a sudo vi LLM app, or let's do LLM resource.yaml. Paste this in. So the name metadata is going to be, let's just say LLM. The name here, I'm going to also call LLM. And the address is going to be the services internal DNS. So let's actually save this. Let's k get services in the namespace of AI. And the service we want is OpenWebUI. So the convention is, let's go back to that file. The convention is that instead of foo.default, it's going to be the service name dot the namespace, which is AI, and then .service.cluster.info. That's just Kubernetes standard, fully qualified service DNS. And then for the alias, let's just do LLM.home, and you'll see how that works here in a minute. And I just noticed this. This is actually supposed to be cluster.local, not cluster.info. So open-webui.ai.service.cluster.local. So with all of this defined, let's go ahead and deploy it. Okay, create F, and what we're doing here is creating the resource. So create F, LLM resource.yaml, resource created. To double check, let's go back to our admin panel and see if we have that as a resource. And there it is, LLM. And then the next question is who can access this application? And that leads us to the Twingate resource access object. So copy this and define what access this resource has in Kubernetes. I'm not going to do that because we've gone a little long here and I have one more thing to show you. So just real quick, let's make sure this works. Let's go back to the admin panel. I'm just going to do this here for sake of time. I'm going to say add access to everyone, grant access. But let's check to make sure this works. So we normally show how you can download the Twingate client or app on your mobile phone and access it that way. In this video, I'll show you how to do it on your laptop. So first things first, let me connect to a hotspot to make sure I'm off my home network. All right, so I'm on a different network. I'll open up Twingate and you'll see that up here. Let's go ahead and log into Twingate and let's try it out. So open up Twingate. I'm going to choose LLM and just open in browser. Let's see what happens. And there's my private LLM that I can access from anywhere. You see up here, LLM.home. And if you didn't use an alias, you would use that entire service address. So that would be open-webui.ai.service.cluster.local. It's just a longer way of doing it. And to test this, let me disconnect from Twingate, log out and disconnect, and refresh, and I get nothing. So I have my private LLM, my private network is not opened at all to the internet, and I can access it securely as needed with Twingate. Okay, so the final thing I want to show you is service annotations. So instead of getting started, we're on this page, go down here to user guide, click on that, and scroll down to the section that says exposing a cluster workload by annotating an existing service. So instead of creating a resource object for all of your resources, one by one, you can actually annotate the services and the Twingate operator will create them for you. So here's an example. Here's a service and all you have to do is annotate it. So here's an annotation called resource.twingate.com, true. And here's your alias, myapp.internal, or in our case, LLM.home. And when this service is deployed, it also creates the resource for that service automatically. And you can add other annotations like a name, security policy ID is visible, anything under this spec property can be annotated. So that's a much quicker way to automatically create these resource objects. So in the case of OpenWebUI, when we deployed that Helm chart in the values.yaml file, there's a section for annotations. Here you could add your annotations, put them in the values.yaml that we created, And when you deploy OpenWebUI, it will also create that resource in Twingate. Very cool. So I hope you found this helpful. The Kubernetes operator allows you to do all of this within Kubernetes and to stay within your environment. So you have your applications and you have your configuration in the same place. And you get all the security and ease of Twingate remote access. If you have any questions, as always, leave a comment below or jump over to our subreddit, link will be below as well, and ask away there. Thank you for watching.